8.2 Swyk number 1. We're talking about a finite geometric series this time, which we've already talked about because I screwed up in one of the previous ones. Sorry. Alright, so we know it's finite. Couple reasons. Number 1, it stops with the last term. We just don't know how many terms there are. Guess what? We're going to have to figure this out somehow. No, guess and check is not an option. Don't you dare do that. Use your brain. Because guess what? In pre-calc, they are not going to let you get away with that. All right, now, we know that the first term is a 3. We know the common multiplier is 2. You can tell because you are doubling every time. Any term divided by the previous term. Any term divided by the previous term. They all spit out the same thing. So we know it's 2. So I take the last term and I set it equal to the formula 3 times 2 to the n minus 1 power. First we divide by 3. Don't you dare multiply the 3 and the 2 together. That's highly illegal in every country of the world. Divide by 3, we get 64. Now, how do you handle this? I recommend logarithms. That's right. You don't want to do logarithms. You thought they were going away. They ain't going away, right, folks? Okay, so the base is 2. Write it in its log form. Remember, the base is 2. The exponent, which logarithm means, there's a single word synonym for logarithm, is exponent that goes on the other side. Therefore, the only thing left is the argument, 64. Of course, my calculator won't do base 2, so I'll change it to base 10, right? Log of the argument over log of the old base. I'll choose 10 because my calculator can handle that. And we can see clearly that it spits out 6 terms equals n minus 1, and then we could just add the 1 to get 7 terms. Now, I know that's not a big number, but you got to remember to use your logarithms because pre-calc will force you to do that. It's not that hard. You can do it. We've done it. Now that we know that there are 7 terms, we can go to the formula, right? Why isn't this moving over? I don't know why. Oh, there it is. Shoo, that was weird. So we know that the first term is 3. We know the multiplier is 2. We know that the n value, the number of terms, is 7. So we type it in our calculator and we come up with 381. Please make sure you're able to type that in and get the right result. If you have to do it one step at a time, like do this part first, then multiply by 3, then divide by that denominator. Now, 1 minus 2, that's negative 1. If you want to simplify that in your head, then just divide by negative 1. Guess what? It'll work. If you want to use the parentheses, you're more than welcome to. But 381 is the answer to question number 1. Question 2, same scenario, except this one's written in summation notation, right? We've got an exponential function here. If you don't recognize that as exponential, then you can plug in the numbers 1, 2, and 3. You're going to find that you start with a 1, then you go to a quarter, then you go to 1/16. Those would be your first 3 terms. So 1 plus a quarter plus 1/16. Now you can see those terms are getting smaller and smaller and smaller as you continue forward. We're only adding 6 terms together. Okay? But where are you going to use the formula, right? We start out with the first term. Remember, you find the first term by plugging in a 1. We know that the multiplier is 1/4, and we know that there are 6 terms. When we type this in our machine, we get 1.333. They wanted it rounded to the nearest tenth, so I rounded it to 1.3. Moving on. What about an infinite geometric series? Oh, no, that's not this one. Gee whiz, I'm getting ahead of myself. So we're starting out at 32, going down to 16, going down to 8, then 4. This must be multiplying by 1/2. So it's not arithmetic. It's definitely geometric. We could see if we take any term divided by the previous term, you're getting 1/2 each time. So definitely geometric. We want the sum. They're telling me to stop with 180 terms. Now I know we see the ... there, but then after that they say n equals 180. So they're telling me stop at 180. Okay. Now, first term's 32. Multiplier is 1/2 to the 180. Now, what's inside those parentheses right here? When you type that on a calculator, the calculator is going to tell you that that's equal to 1. Now, is it equal to 1? Not really, but it is so close to 1 the calculator can't see a difference. That's how far out the decimals go. So it says, it's a 1. All right. So then 1 times 32 is obviously only 32, and then you divide by the 1/2 on the bottom, you get 64. So the sum of that whole thing is 64. Next. Now, here's the infinite one. Can you add up an infinite group of numbers? Only if they're getting smaller, and only if it's geometric. Okay? Now, when can you do that? Come over here and look at this information over here. Maybe I should zoom in on it. Maybe I should put if the absolute value of r is greater than or equal to 1. This is going to cause the terms to get bigger and bigger and bigger and bigger and bigger. Not good. You can't add an infinite group of numbers when they're all getting bigger. That is what we call, it says it diverges. Diverges is more than just this significant desire to jump into a swimming pool. Yes, that is a wonderful dad joke. But diverges in the mathematical world means it's getting farther and farther away from a single number, or it's not equaling a single number. So in that case, when we say that it diverges, there is no sum. Don't waste your time trying to find a sum, because there isn't one. But if the absolute value of r is less than 1, then it converges. Converges means it gets closer to a single number. And it's not going to exactly equal that number, but we say that it gets closer and closer and closer and closer to that number. And that has everything to do with what we call limits, which is something you'll talk about in pre-calc, not in Algebra 2. The sum of the infinite number of terms is first term over 1 minus r. This formula is actually easier than the finite version. Yeah, it's much easier. I would recommend parentheses around that denominator, though. People really mess things up. Now, in this particular case, on this particular problem, we are multiplying by 1 over 8. You can take any term, divide by the previous term, and you will find that we are multiplying by 1 over 8. Top gets multiplied by 1, bottom gets multiplied by 8. So, is the absolute value of 1/8 less than 1? Sure it is. Therefore, the answer is yes, it converges, so we go to the formula. Now, if I zoom in here on the formula, what I want you to see is my first term was a 1. It's just, that's not a part of the formula. I had to actually go figure it out or look, and this one actually showed me we started with a 1. If it started with a 17, I would have put a 17 right there. On the bottom, we got 1 minus 1/8. Now, 1 minus 1/8, back to our pre-algebra days, was 7/8, right? 8 over 8 minus 1 over 8 is 7 over 8. Okay? Now, the reason I'm doing this with fractions is because they won't accept the answer in Math Excel unless it's in fractions, so I'm trying to show you so you don't panic. Notice that this thing right here, 1 divided by 1 7/8, I wrote it horizontally right next to it. Now, there's a reason why I did that, because you guys remember back to your middle school days where they said things like keep, change, flip, something like that. Division is the same as multiplying by the reciprocal, so you can change it to multiplying by flipping the second fraction. So that means we're going to get 8/7 as our answer to this question. Since they want it in fractional form, that is the answer. All right, let's see about the next one. If the so we can see that we're multiplying by 3 each time. Is the absolute value of 3 less than 1? Heck no! It diverges, therefore no sum. Boom. Don't waste your time doing anything else if you already know the absolute value of r is not less than 1. Next is the absolute, here we go. We're multiplying by negative 1/8 each time. Is the absolute value of negative 1/8 less than 1? Sure is, so it converges. Therefore, we can use the formula 1 over, right? My first term happened to be a 1 again. Man, it's like a magic number on these things. So first term was a 1 over 1 minus 1/8. Really, that becomes 1 plus 1/8, so that's why you get 9/8 on the bottom. 1 divided by 9/8 is the same thing as 1 times 8/9. So that's why your final answer is 8 over 9. Now, at first you're saying to yourself, well, wait a sec, how in the world can you have an answer for an infinite geometric series, or infinite group of numbers, and it's less than 1, when the first term actually started out being 1? Well, remember, because they're going positive, negative, positive, negative, positive, negative, positive, negative. That's the end. That's the only reason that ends up happening, is that it ends up being lower than 1. Okay, that's enough for that, Swyk.